Today we shall see about field effect transistor. This is another type of transistor. So let's see about what is the difference between a BJT and FET. BJT is bipolar junction transistor. Normally you can find that there are three terminals and you have emitter, base and collector, and in FET you have source, drain and gate. The next point is BJT is used as current control device and FET is used as voltage control device, and BJT is a bipolar device wherein you can conduct in both the directions, whereas your field effect transistor is a unipolar device which conducts in only one particular direction. Then you have two types of transistors. One is NPN, the other is PNP. Similarly, in FET there are two types. One is called as the junction FET, the other is MOSFET. So this is the classification of FET. So you can find that the FET is being splitted into two types. Like you have a field effects transistor, is you have a junction FET, and below that again it is splitted into depletion mode. Under depletion mode you have an N channel and P channel, and the other is you have on the right hand side we can find that you have a metal oxide semiconductor field effect transistor, we call it as MOSFET. So you have depletion mode and the other is enhancement mode. Again in depletion mode you can find we have N channel and P channel, and in enhancement mode we have N channel and P channel. And as I've already told you that BJT have two types, one is NPN transistor and the PNP transistor. We shall just move on to the next slide. So the construction of N channel FET. So you can find the pictorial diagram on the right side is being illustrated, where you can find that the major part of the structure is N type. Exactly, it forms the N channel, and on the top of the N channel it is connected to a terminal which is referred as drain, and at the bottom you can find it is being connected to an ohmic contact to a terminal which is referred as source. So P type materials connected together and they are termed or called as gate. So junction FET has two PN junctions under no bias conditions. So now we shall just move on to the operating characteristics of gate source of an FET when gate source voltage is equal to 0 volt. So three things happen when your gate source voltage is equal to 0 volt and your drain source voltage is increased from 0 volt to more positive voltage. Here we find that there is a depletion region between P gate and N channel increases as electrons from N channel try to combine with holes from the P gate region. Increasing the depletion region decreases the size of N channel, which increases the resistance of N channel. So some of the operating characteristics. So there's a special characteristics, we call it as a pinch off as far as your junction FET is concerned. So here you find the condition, it says that whenever your gate source voltage is equal to 0 volt and your drain source voltage is further increased to a more positive voltage, then we find that the depletion region gets increased and pinch off takes place at the N channel. This suggests that current in N channel, drain current would be dropped to saturation. So now we shall move on to the drain characteristics of junction FET. So the graph shows it's a plot between drain source voltage versus your drain current for different values of gate source voltages. So first initially we can find that when your gate source voltage is equal to 0 volt, and when you increase your drain source voltage is a positive value, you can find your your drain current increases linearly, and when you try to increase more you can find that your drain gets saturated, and it is being represented as IDSS, drain saturation. And now next thing what you do is, now you make your gate source voltage negative and you find that VDS is positive. Again here you find the drain current, now it reduces from the previous value of ID. So this is the transfer characteristics of FIT. So it is a plot between gate source voltage and drain current for a fixed value of drain source voltage. So when your gate source voltage is 0 volt, ID is IDS, and when VGS is more negative, the drain current ID reduces. Thank you.